since you were pretty small. Because you guys know the inverse operation of adding 6. What is the inverse operation of adding 6? Subtracting 6, right? You know the inverse operation of multiplying by 2. What would the inverse operation be? Dividing by 2, right? So it is as simple as that, but of course we're not leaving it as simple as that at the pre-calculus level. We're taking it further. So those two functions that we were just looking at on our warm-up are inverses of each other. So what it means is if I plug a number in to one of these functions, it's going to give me something out. Well, if I take that number that I get and plug it back into this function, it's going to undo what was done, right? Just like adding 6 and subtracting 6 undoes whatever was done, right? Subtracting 6 undoes the adding 6. So whenever we're trying to find the inverse of a function, we're trying to basically find the function that reverses whatever happened in this. So the reverse of multiplying by 2/3 and adding 5 is going to be to subtract 5 and then multiply by 3/2. Or you could think of it as dividing by 2/3 right there, right? So you're always going to go sort of like in the opposite order of whatever you did. So here, if we were doing order of operations for this, we would multiply by 2/3 first, then we would add 5. So on the inverse, you need to subtract 5 first, so that's why we have that in parentheses, and then divide by the 2/3. In this case, that's the same as multiplying by 3/2 for that. So these two would undo what was done there. Some notation. Inverse notation for functions is going to look like this. It's f to the -1 power of x. So whenever you see f to the -1 power of x, that means the inverse of x. Okay, and so I have graphed a few functions and their inverses. I should have been more consistent on my colors here. And each one of these, I have also graphed this line y equals x. So y equals x is just this line right here that splits the first and third quadrants in half. I should have used green for all of them, but for some reason I switched my colors up in this middle one. So if two functions are inverses, then whenever we look at one of the graphs, if we flip it over that line y equals x, it will give us the other graph. So for example here, this is an exponential and this is a log graph. So like if this is e to the x, this would be natural log of e, natural log of x. So so you can see how they're reflected there. Lines here, if you have a line, its inverse is also going to be a line in that case. I believe this was something like x squared was this black graph right here. And then if we reflect it, we're going to get a square root graph there. So square roots and squares are inverses of each other. One thing to note about what you're going to see here is on these graphs, if I have a point, for example, let's just use this point right here. The point on this graph right here would be 0, 1. If 0, 1 is on the graph of a function, then 1, 0 is going to be on the graph of the inverse, right? So like if I pick a point right here, let's do this point, which is -4, 0, then 0, -4 is going to be on the graph of that inverse. And that would be true for other points. So like if I pick this point right here, which is 5, 9, that means 9, 5, which is right here, should also be on the inverse, right? We could even do that here. So the point right here is 2, 4. So that means 4, 2 will be on the inverse. So if we just had like a table, we could create an inverse just by switching our x and y values for that. Okay, questions there? All right, so One thing you may be asked to do is to graph an inverse. So, to graph an inverse, you can reflect it over the line y equals x. And if you're really, really good at doing this stuff visually, here, let's see, which I am not, then you would just think, well, that line right there is my y equals x line. I'm just going to flip all the points. I have a little trouble picturing that myself, particularly if I can't like fold the graph on that line. But if you need to graph an inverse, what you can do is you can just take all the points that are on grid lines. So like for this, we've got this point right here is -3, 6. Then we've got -2, 3. We've got -1, 2. We've got 0, 3, and 1, 6. And we can just switch them all. So switch the points. So that means -3, 6 will become 6, -3. So 6, -3 is right here. Use a different color for my inverse. So use red. Then -2, 3 is going to be 3, -2. So 3, -2 is here. This is going to be 2, -1. This is going to be 3, 0, and 6, 1. And so then, once you flip those points, you can usually kind of tell where the graph goes. So you can see like 1, 6 became 6, 1. Here, I'm not going to write all those out. Questions? The second one, I think it's a little bit easier to do sort of visually, but you can make sure that you get points exact on this. It's not quite as easy as far as where the points are at. Anything that actually touches that line y equals x is not going to move. It's going to stay right there on that line. So if I pick some points, maybe like this point right here, which is, let's just count by 2s, so that would be 12, 10. If I flip that, it's going to give me 10, 12, so 10, 12 would be right here. This point right here would be 16, 14, so I'd be looking at 14, 16, which is going to go, hold on, that doesn't look right. That's 16, 12, 16, 12. So 16, 12 would be 12, 16, which would be right here. That looks better. Then maybe like this point right here, this end point, is probably at -2, -5. Oops. So that would be -5, -2, which is right here. So if we kind of draw that in there, this blue graph right here would be our graph of our inverse. Okay, questions? Okay. All right. So let's look at what we're going to do. That's kind of looking at it graphically. Let's look at it what we do algebraically. Okay. So algebraically, These are our steps that we're going to use to find the inverse. So, and there, I'm going to put like a little asterisk here. There is something that we need to know about like domain for this stuff, but I have that in a separate section that we're going to look at on Monday. So right now, we're going to kind of ignore domain, and we'll talk about that separately on Monday because sometimes putting that all together can kind of confuse you a little bit. We'll talk about that on Monday. So if I want to find the inverse, and I think, have you guys found inverses before? Does this seem familiar? I think. You are going to switch your x and y variables, solve for the y, replace it with f inverse of x. So what that's going to look like here, the f of x, we're going to treat it like our y. We're going to switch where our x and y are at. So that is going to be x equals 2/3 y minus 5. Okay. So then we want to solve for this new y to get our new equation. When I say solve for y, it doesn't mean you're going to get something like y equals 6 most of the time anyway. You're going to get a new equation that's y equals something. So to solve for that y, we would want to add this 5 right here. So we would have x plus 5 equals 2/3 y. And then what would we have to do next? To get that y right there by itself. Divide by 2/3. And dividing fractions is easy as pie. We're going to flip the second and multiply. So, to make it a little bit easier, because I generally do not want you to leave, like you could do it this way, divide by 2/3, but I don't like you to leave what we call complex fractions, where we have fractions inside of fractions, because if fractions weren't bad enough already, to put more fractions inside of fractions is just confusing. So the other way that you can deal with this is you can just go ahead right here and multiply by the reciprocal, because that's essentially what you're doing whenever you divide, right? You're flipping the second and multiplying. So you could multiply by 3/2 and multiply by 3/2 over here. Because dividing by 2/3 is the same as multiplying by 3/2. So you may see the answer left like this. We have 3/2 times x plus 5 with the parentheses around the x plus 5. Or you may see the answer where they've distributed out that 3/2. So that would give you 3/2 x plus, how do you multiply fractions? Where are you going to get there? What? Yes, there's a good chance they're going to leave it as fractions instead of 7.5 though. So this is 5/1. To multiply fractions, we just multiply the numerators together. We get 15. Denominators together, we get 2. 7.5 is fine. I am happy if you put 7.5. It's just that these are usually multiple choice, so they might be fractions instead. And then we can replace that y with the f inverse. They may or may not distribute that 3/2. So you're just going to look at your answer choices and see which way they've left their answer. Either one is fine, but you will not see both of them as answer choices unless I've made a mistake, and then you need to let me know because you might get a bathroom pass for that. Okay. Questions? Okay, here's another one. We've got g of x equals x plus 5 to the 3rd power minus 7. It's asking us to find g inverse of x. So that g is like a y. We are going to switch the x and y. So we'll have x equals y plus 5 to the 3rd power minus 7. we've got to solve that for this y right here. So, Troy, what's the first thing you would do to solve that for y? Very good. That is what we should do. So we got x plus 7 equals y plus 5. Ugh. This thing does not like it when I write 5s. I don't know why. All right. Maggie, what do you think we would do next? We got to get rid, we don't want to like try to like expand it out, but we need to get rid of that third power. That's the next like step in that we've got to deal with. So what can we do to get rid of something to the third power? What? Cube root, right? A cube root will get rid of a third power. So we could cube root both sides. So now we have the cube root of x plus 7, and that gives us y plus 5. And then we need to get that y by itself. Lee, what's the last thing we would do to get good? We'll subtract that 5 because we're trying to get that y by itself. You can write it a couple different ways. Typically, you're going to see it written like this. -5 plus the cube root of x plus 7 equals your y. It is also okay to write it like this, the cube root of x plus 7 minus 5. The reason you're not going to see it written like that as often is because if you just accidentally draw your square root line just a little bit too long there, where it looks like that minus 5 is under the square root, then it's wrong. Because that 5 is not under, that -5 is not under the square root. So you're going to see this more often, but either is okay. So our G inverse of x is -5 plus the cube root of x plus 7. Now, you're definitely going to have to be able to do some of these without Desmos. But I want to say this is, I can't remember. I know there is a calculator inactive part of this test. I can't remember if it is all calculator inactive or if it is, if there is some that you can use the calculator. But while we're learning how to do this, there's a reason why I'm not letting you use Desmos, but it's still good for checking your work, like when you're working on homework. So this is, Desmos is so cool. So g of x equals x plus 5 to the third power minus 7. So there's a couple ways you can check your work here. You got y, if I type y equals x, that puts that line that should be our line of symmetry. And then if I type in my inverse, I'm just going to call it y equals -5 plus the cube root, which I've got to go over here for cube root of x plus 7. I can see that looks symmetric, right? So that is a good way to be able to tell, like, sort of if it looks like it's right. But there's an even better way, because Desmos will let you do this. X equals y plus 5 to the third power minus 7. The part where you switch your x and y's up here, if you switch your x and y's here, it will graph it for you. Notice that's the same as what we got for our answer. So that green graph we got for our answer is the same as the original function with the x and y switch. So that lets you know you solved it correctly for that. So you're probably not going to be able to use that. I know you're not going to be able to use that on all of the tests. There might be a section where you can use it, but I will expect you to be able to do some inverses without having Desmos. So you don't want to use this just to do all problems, but it's a good way to sort of check if you're right or not whenever you're working these out. So I just want to let you guys try this one. I love these. And I want to see if anybody can do it. Usually nobody can do it. But you guys might be smarter than usual. I don't know. Every once in a while somebody has the right idea on this. So I'm going to pause mine. It may still be correct because there are several ways the answer can look for this problem. So what I did here is I multiplied both sides by 9 minus y. See how I put this in parentheses over here? That x has to be distributed to both of those terms, giving you 9x minus xy. And then you want everything with a y to go to one side and everything without a y to go to the other side. So you're going to take this y and subtract it to move it over here. And then this 9x is in your way over here because it does not have a y, so you move it over to this side by subtracting it, and you get a negative 9x right there. So you should have negative xy minus y equals 2 minus 9x. So everything with a y on one side, everything without a y on the other. You're going to factor out your y right here. So when you pull that y out, you're just left with a negative x. And then, like, technically, it seems like you don't have anything left here. But there has to be something left there, or else it won't multiply back together correctly. So there's a 1 there that you can't see. So that 1 is left when you factor it out. And then your last step is just to divide by that. So you're going to get 2 minus 9x over negative x minus 1. Okay, questions? These aren't necessarily easy. They're so fun. I think they're so cool, though. So, does anybody's answer look different than that, but you think it might still be right? What'd you get, Gabby? Okay, so negative 9x plus 2 over negative x minus 1, perfectly fine. The just numerator is different. It would be the same if you did a 1 minus x on the bottom, right? I'm sorry, negative 1 minus x on the bottom. You can switch the order of those. You also might see it, like, depending on which side you move your y's to, because I typically always move my y's to the left side. I just like them better over there, but you technically could move them over here as well. You could end up with something like this. F inverse of x would be like 9x minus 2 over x plus 1. Okay, that is going to be the same, and let me show you why. If I take this and multiply it by negative 1 and the bottom and take it and multiply it by negative 1, I am not changing the value of that function because negative 1 over negative 1 is just 1, right? So it doesn't change the value. So that would make me have negative 2 plus 9x over positive x plus 1. And then if you wanted to, you could write it with that 9x first. So it would be the same. So I made the mistake a few years ago of giving some of these problems on Canvas where you had to type in your answers. And I thought I had typed in a couple different options of like how you would type in your answers. I was terribly wrong because there are a lot of different ways that your answers could look for these and still be correct. So this is something like, you'll probably see it on quiz or test, but you'll probably only see maybe one. And you don't want to, if your answer, the exact answer is not there, you don't want to necessarily give up immediately because it may just be like a, switch something or multiply the top and bottom by negative 1 and you can get it to match. All right, try one more of those. You got one more there. That's what I got. So I'm seeing lots of correct answers when I walk around this time. So here's what I've got. Negative x minus 4 over 2x minus 1. If you got negative 4 minus x, that's the same, right? I saw a few of you that had it written backwards from what I have, but it's still mathematically equivalent. There's no correct way necessarily to write that there. So, similar process as the last one. Multiply, distribute. Everything with y's goes to the left. Everything without y's goes to the right. Factor, divide. Okay, questions on that one? All right. Okay, there is one more thing that we need to talk about. Okay, and our warm-up kind of led into this at the beginning, right? So I was talking about if we had something like f of x equals x plus 6, then we would know f inverse of x would be x minus 6. Inverses are the functions that undo each other. All right. So if a function is the function that undoes another function, when we compose those functions, we should get x every time. So in those two blanks, you should get an x there. These two I've put up here are like a really simple one to help you understand. If you do f of f inverse of x here, you would be doing x minus 6 plus 6. Clearly, if you do x minus 6 and then do plus 6 right after that, you're just going to get whatever you started with, right? Same thing if we compose the functions in the opposite order. So if I do x plus 6 minus 6, I would still just end up with what I started with, which would be the x. So, one thing that you are going to be asked to do is to prove that f of x and g of x are inverses of each other. And so, it is true that I could just switch my x and y's and solve this. And if they match, then it should be right. But when I say prove, what I am wanting you to do is to do f of g of x and g of f of x. The way that I'm going to ask this on like the quiz or the test is that I'm going to say are f of x and g of x inverses, and one of your answer choices is going to be yes, because f of g of x equals x and g of f of x equals x. So if it is a yes, you could probably just do it by switching your x and y's and figuring out what you have there. But if it is a no, it's going to say no because f of g of x actually equals 2x plus 7. So if you didn't do f of g of x, you won't be able to answer it if it's a no problem. If it's a yes problem, if you get lucky and it's a yes problem, then you might could do it without knowing how to do what I'm about to do right now. Okay, so all we're going to do if we're trying to prove that they're inverses is we want to find f of g of x, right? Which means that we would take g of x and we would plug it in over here for our x. So that would look like this: 2x plus 5 over 2 minus 5. And when I used to give this test on paper, I used to make you show your work on this. It is important that you know what's happening here. What is going to cancel first when I'm simplifying that? The 2's cancel first. This is like a 2 over 1, so 2's in top, 2's in bottom. Those are going to cancel. That is going to give us x plus 5 minus 5, and then clearly those 5's will cancel, so we'll just have x. I have never in my career ran into a problem where f of g of x equals x and g of f of x does not equal x. However, I have not seen one in a textbook. I have not seen one on an exam. I've not seen one anywhere where it can work one way and not another. However, you are supposed to check both ways. That makes me think there's probably actually a function out there where it doesn't work if you reverse it. I just don't know what that is. So the second step is going to seem unnecessary, but you are required to check this as well. So if I'm asking you to prove you want to do f of g of x, you also want to do g of f of x. So g of f of x means we would take f of x and plug it in right here. So this time it would look like this, 2x minus 5 plus 5 over 2. What is going to cancel first this time? The 5's. So we'll have 2x over x, and now the 2's will cancel, and we'll just get an x right there. So this would prove that they are in fact inverses. Yes, f and g are inverses. Because we've shown if we do f of g of x, it undoes what was done, and we just end up with the x that we plugged in the first place, right? So this is what I'm looking for. I'm going to change the question a little bit for 7. Okay? So for 7, I'm going to change this to r f of x, and I'm going to make that square root. It should extend. I'm going to change this to a plus sign right here. And instead of saying prove that they are inverses, I'm asking the question, are they inverses? And justify your answer. This is a little bit more like you'll see on the test or the quiz. So if I'm asking, are these inverses, and I purposefully have changed that to a plus sign because I want the answer to be no on this one. So you see what it looks like when it's a no. So if I do f of g of x, that means I'm taking all of this stuff right here and I'm plugging it in right there for that x. I'm going to get 3 plus the square root of x minus 3 squared plus 4 plus 4, right? Because this stuff right here, that was my g of x. Now, if I had left it a minus 4, I would have a minus 4 and a plus 4 and a minus 4, and they would cancel out. And then eventually I would get that these are inverses. But do these 4's cancel out? They do not. So that means I'm getting 3 plus the square root of x minus 3 squared plus 8. Can I simplify that any further? I might feel like I could, maybe that square root and that square right there will cancel each other out, but that's not going to be the case if I've got that plus 8 on the end. If you have, so if I have, square root of 4 plus 1, that is the square root of 5. It does not equal the square root of 4 plus square root of 1, which would be 2 plus 1, which is 3, right? That would be wrong. You couldn't do it that way. So if you've got a plus or a minus sign inside of a square root there, you can't square root those separately. So that 8 is messing you up there. So these can't be inverses because that's not going to simplify down to give me x. So I could say no because f of g of x equals 3 plus the square root of x minus 3 squared plus 8. Which, if you want to put right here, which does not equal x. Right? If you get anything in the world besides x, it could be super complicated or super simple. It could be x plus 2. then that does not equal x, so it is a no for that. So what it'll look like is the question will say, are these inverses? And then you'll have answer choices. Probably one of the answer choices is going to be yes, because f of g of x equals x and g of f of x equals x. The other answer choices might be something like no, because f of g of x equals this. And then you'll have other ones. So you'll have some options there, so you have to be able to do this to tell which one that you would get right there. If you get a no, you don't have to check the other ones. So if f of g of x does not equal x, you don't have to check g of f of x for that. Although, look at your answer choices, because it's possible like all the answer choices are g of f of x, and you might need to check that. If that's the case. Okay. Questions?